Hey everybody, today we will do another problem and we will do maybe one or maybe another, this in another video probably is going to be in this topic. So source transformation, I have a problem right here that says that has a current source of 10 amps and then it has one resistor in parallel with that one, and then it has another voltage source of 50, right? 50 volt, right? And they want to find this current. They call it IX. Okay, so doing the source transformation, right? So we need some values for that, which are 10 and 20. 20 ohms, 10 ohms. Okay, so source transformation, right? So we will do source transformation because this problem is one of this problems in this book on the study guide for the fundamental of engineering exam, FE, electrical. So I will do this in source transformation, and then that way give us a little practice to solve this using the source transformation and the KVL type, right? Using the KVL. But then we can actually do this other ways too. We can do it with superposition, right? But again, we're doing this for practicing how to solve problems because problems cannot just be solved one way, right? So I mean, most of the problems. So we need to learn different techniques how to do things. And in real life, that's how it works too. Unfortunately, it would be nice if I can get a formula and that formula works for every problem, but unfortunately, it doesn't work that way. But anyway, okay, so we have this, right? We are asked to find the current at this point, right before it goes into the voltage source, right? So as you know that it doesn't have a resistance here, it's just a wire, right? This point is just a wire. They want the current going in that wire, right? Okay, so I need to find that current, right? This current, right? So if I want to find this current, right? So how do I approach this problem? What source transformation, right? So source transformation, I have this resistance in parallel with this current. So I do V, right, is equal to IR, right? So V at, you can say whatever, 10 ohms is equal to what? It's going to be equal to V is equal to 10 times 10, which is equal to 100 volts, right? So now I got this transform, and what do? I transform it, right? I transform it to a series circuit. This is in parallel right now with this current source. that will become in series. So this will become a voltage source, right? And it's going up, so I can assume that it's going from negative to positive, and it's going up, and then I will have this resistance that was in parallel now will become in series, and that will be a resistor of 10 ohms, right? And it's going to be in series with 20 ohms, and then I will have the current Ix, and then I will have this voltage source that's going right here from negative to positive, and it's going to be going like this. Notice that right now I have two voltage sources, right? So this right here is 100 volts, and this right here is still 50 volts, right? So now they are both in series, right? But I have two voltage sources, right? What can I do when I have two voltage sources? I can add them, right? I can add them. Making sure that this is a plus, this is a minus. Okay, so this is a plus, this is a minus. So that means that this is a positive 50 volt, and this is nothing but basically 100 volt negative, right? Because I'm going up, right? Now, what can I do, right? So using KVL, I can say that a negative 100 volts, this one, right, is going, and then plus, you can call this I, but technically I am looking for that. I am looking for the current going in that loop, right? So you can call this I, right? You can actually call it, this I1 and I2, whatever, but then, it's the same thing. So we can actually say that plus I X, because it's in series, so the current is the same, right? This transformation, after I do this, right? So because it's going to be to have two voltage sources in series, is going to be I am using KVL, right? But I am saying that those voltage sources are in series, right? And then those two resistors are in series, so therefore plus Ix, right? Plus again Ix of 20 ohms minus, right? So this right here, I'm sorry, this is a plus, right? It's a plus because current is entering this positive, so this is a plus 50 volts is equal to 0, right? That's KVL, right? Now KVL, and KVL has to work, right? Apparently there is a professor from MIT that he want to be the smartest guys in the world, but he doesn't believe in this, that this exists, right? I'm not gonna get into that. He can be the smartest guys in the world, but actually, I'm not gonna, get to that. To start open that can, that can of worms right now. So no. But anyway, KVL to work, right? Okay, so this one right here, 50 volts, right? So I get negative 50 volts, adding this and this, I get negative 50 volts, and then I add this two, which is Ix times what? Times this and this is 30 ohms, right? And that is equal to 0, right? Okay, so now I can do this on the other side, and I get what? I get Ix is equal Ix at 20, so at 50 on both sides, right? At 50 on both sides, and I get 30, right? IX at the resistance multiplied by the resistance of 30 ohms, right, is equal to 50, right? Divide by 30 on both sides, and we got that IX is equal to approximately 1.66 and whatever is happening, right? Which this can be round to IX is equal to 1.7 amps. Right. So that is the way that we do it using the source transformation and with the little formula using the KVL, right? Using the equation, using the equation of KVL, we came up with that value. Okay, now let's do it with the other way, right? Let's do this with a superposition, right? Now, let's do it with a superposition. And this is the thing that I'm talking about. When you're doing this, you need to find out which way would be the easy way for you to solve a problem, right? As long as you get the right answer. Okay, so now this is the circuit, right? Superposition tell me and I will be probably do more videos on superposition, but this is superposition, right? Superposition. Okay, so superposition, right? So superposition tell me that I need to somehow short one side, and if it is a voltage source, I short it, right, with the wire. If it is a current source, I open it, right? Right. So if current, right? If, okay, if there is a current source open, right? So this is right, and then if there is a voltage source, right? Close it. Right? If there is a voltage source, close it, right? What do I mean? What do I mean by closing it? Well, mean shorting it, mean just make a line through it, right? Now, or you can say short it. I mean, it doesn't really matter. I mean, it's so. All right. Okay, so now in this case, so what do I do? Right? I shorted this, right? And I get right? This is 10 ohms. and then I go, this is IX, right? This is not voltage source. I mean a current source, it's just IX going down, and I replace that by replace the wire, the voltage source was replaced by just by a wire, right? Okay, now I need to find the current going here, right? Now I can use current divided rule to find out what is going on in this. So, okay, so this is 10 amps, right? So now 10 amps. So I, right, you can call it IX1, right? So IX1, right, the current going here, right? You can say that IX1. So what is the rule for current divided? Well, it's that whatever I care goes on the bottom, whatever I don't care goes on the top, right? What do I care? The current going in this guy, because this is the closest going to this, right? The current exited, when it exit this side of the node, right? This side of the resistance, and so that's the one that I'm looking for, right? So now, let's do this. So now let's do this, and we find out the current in this guy, right? In this. So how do I do it? Well, this is the one that I care. This I don't care. So don't care goes on the top, 10, right? And what is the current? And multiply that by that current, which is 10 amps, right? Multiply by the current, and then I am divided by the one that I care plus the one that I don't care. Which one I don't care? I don't get about the 10 plus the one that I care, which is going to be 10 plus 20, which is equal to 100 over 30, which is equal to 3.33 amps. Okay, so now we have that, right? So that is called IX1, right? Now I need to do the other side, right? I need to open this one, and keep that closed, right? Now, okay. So open. Now let's do the next one, right? So let me keep this one and open this one. So I do. So right, open. Right? So then, so this is the guy is opening now, right? Now I have what? I have another resistor. Right? And then I have a voltage source, right? Plus and a minus, and I go on, right? So now this is 50 volts, right? Notice that this is 10, this is 20 ohms, right? Okay, so now notice that this is open, right? So this is like a serial circuit because this is open. Doesn't matter, current is not going through here, right? Not even voltage, so nothing is going here. So assume that this is actually a serial circuit. Okay, so what do? I do I do what? I do the sum of the resistance, right? Which is going to be, it's going to be 10 plus 20 is 30, right? And I can call that IX2, right? You can say that IX2 times 30, right? And it does 2, right? And it does 2 times 30 because this is in series now. Right? Plus, right? Plus this guy because it's going into this is what I'm looking for, right? I'm looking for this. I'm looking for that IX, right? Now that one is entering this, so therefore that current is entering the positive, so it's a positive 50 volt is equal to 0. See, another KVL little guy, right? Okay, so now I subtract that 50 volt to the other side and I get I30 is equal to negative 50 volts. Divide that by 30 and I get that Ix is equal to negative 1.667, which is equal to, technically, you can say that it's approximately 1.7 amps. All right. All right, now we can say that this is X, actually, let's call this X2. Yeah, I'm sorry, X2. X2, and call it X2, right? So now when I do that, right, so then I guess what? Now I can say that Ix is equal to Ix1 plus Ix2, right? So now Ix1 is a negative, right? This is a negative, right? Negative. I forgot the sign, but it's negative. 1.7 amps. And I can say that yeah, so this is going to be, and then you take that, and I'm pretty sure that it's going to be very close. So plus, right? So 3.33 plus negative 1.7. Very close, right? So actually, if you don't round this, I just keep it as it is. Just keep this as it is, right? So don't, yeah. And then you add those together, right? So Ix is equal to what? It's going to be equal to 3.33 plus a negative 1.67, and it is going to be very close to that. Okay, plus 1.66. So it's going to be equal to 1.7 amps. Very close, right? So 33 plus negative 1.667. Yeah, it's pretty close. So that number came out with, like, honestly, it came out with a number like this: 6, 3, right? Which is very close to 6, 6 amps. 1.7 amps, sorry. Right, so you can see that we came out with the same answer doing it both ways, right? Now the question is, what way would be the easy way? Well, I think the first way was the easy way to get this problem done. That's what I think. But again, this depends. This is up to you. Which one you find? Which way you find it easier? Right. Thank you for watching, and subscribe to the channel and share and give me a like. Thank you for watching. See you in the next video. Remember, this is the Conservative Engineering Academy, and we learn a little bit every day because Jesus is good. Thank you for watching.